Thank you for having me. All right. If you have any questions, feel free to raise your hand in the middle. We don't need to wait till the end. And if you want to ask me questions after, I'll be around for a little bit. And then that's my email address. Very easy, josh@pubnub.com. Now, in this talk, if you walk away with nothing else, I want you to just know three things. One, that in the future, pretty much every app and device is going to be sharing something, probably a lot of somethings. If you are considering sharing any sort of real-time data, do not build the infrastructure yourself. Use a data stream network. And by ask, which is we are working on a next generation product that we need some alpha testers for. So I would love for you to join our program. So about me, my name is Josh Marinacci. These are not actually my children. These are the default stock children that Apple gave me. And my actual child's photo is missing because he moves so quickly that every photo is blurry. But all you need to know about me is I used to be an engineer. I worked at Sun. I moved into developer advocacy at Palm on WebOS. And then did research at Nokia for 3 years before deciding that Nokia had no idea what it wanted to be. So I've joined a startup, which is, fun and chaotic, but the startup knows what it is. What we make is a data stream network. Now, raising a kid, I've learned a few things. Children today are different in some way, and the way that they interact with technology. So my son is 4.5 years old, and for him, all screens are touch screens. Like he tries to tap the dock icons on my Mac, or at least he did until he finally learned that it wouldn't do anything. He has no concept of what physical media is. Like he knows what a CD is, but to him a CD is a thing that I burn in my computer like a floppy disk. The idea that you would go to a store to buy music is completely foreign to him. Music is something that's in a device or it's streamed from the internet. Everything he watches, his television is Netflix or PBS Kids app on a Roku. The idea that there's a show that's on at a certain time, and if you didn't watch at that time, it's over. It's completely foreign to him. There is no so everything is instant all the time. He does know very much about batteries and internet. When he plays with his iPad, those are the two things that he cares about a lot. And he very quickly learned how to read the numbers, and he will say, oh, the iPad's at 100. That's good. That means I can play for a while. And he wants to share. He loves creating things and sharing them with people. He will, a lot of kids have imaginary friends. My child has an imaginary YouTube audience. He will actually narrate. He'll be at his craft table playing with his Play-Doh and narrate to an audience that does not exist the little video that he's making. And he'll say, hi, you guys. Thank you for coming to my video. This is Jesse's Craft TV. Today we're going to make a dinosaur out of Play-Doh. It's very cute. What it made me realize is that sharing is something that is just innate to humans. It's in our DNA. No matter what technology we have, we're going to want to share. So my predictions for the next 100 years. First of all, that we will still wear jeans. I've heard things about jeggings. I really hope those don't take off. We are still going to eat real food. Doesn't sound very appetizing. And we'll probably take photos of that food and share it. Because humans like to share things. Now, when we use our technology, there are a lot of things that we share. We chat. That's a form of sharing little bits of text. We share lots of files, pictures, and videos. We share hearts and likes, and it really annoys me that like has become a noun. Like is not a thing, it's an action, but we needed some physical representation of liking things. And I really want an unlike button. And occasionally, instead of friending someone, I want to enemy somebody. Like, don't ever show me that person again in their friend list. We share our status, our presence. Are we online? Where are we physically? We're getting to the point where you could actually share your mood. Whether or not that's a good thing is questionable, but once we just figure out how to do it, then we need to figure out when is the appropriate time to do it. We also share things coming out of our sensors, temperature, CO2. At the office, someone hacked together a little scale underneath the coffee machine so that as the coffee pot fills with coffee and it reaches a certain weight, It lets the company know, hey, the coffee is ready. Which gets to our devices. We have lots of devices, and they are sharing things too. They will share, first, their presence on the network. Despite the fact that we've had peer-to-peer protocols for 30 to 40 years, this is still shockingly difficult to do accurately. If you've ever tried to connect to a printer that says it's online but can't find it, or you try to connect to, you cannot find the file server that you know is in fact online, just getting things connected together is very difficult. Sharing environmental data. This is becoming more and more important, and as environmental sensors get cheaper and cheaper, we can start actually having, thousands of temperature sensors all around the city and actually know with a high degree of accuracy, real time, what the temperature is like in any part of the city. We also share the data that we are collecting or generating. And I separate this from actually explicitly sharing, like I took a video, I'm sharing it with my wife or my mom. But we have systems which are sharing the stuff on our behalf. It could be as simple as sending it to the backup server. It could be certain photos are automatically shared to a certain small group of people. Like any photo I take automatically gets shared to my wife's account, so she has access to it. And then actuation, which is sharing back to the device. So if you search for Internet of Things, you're going to come across this chart from Cisco that's like 20 billion or 50 billion devices by the year 2020, and you can just search for it. Then I tried to find, I said IoT chart 20, and I came across this. What amuses me is not that there's a comic about how the Internet of Things is going out of hand, but that it has now become stock art. This is such a regular thing that people need it for their presentations. Now, if you were building a system where you have users who want to share something small with each other or with devices, building it's very easy. Thanks to the last 10 years of web technology and things like Arduino and Raspberry Pis, you can build to get a small Internet of Things device. You can build a chat application very quickly. Cordova lets you, also known as PhoneGap, lets you write your JavaScript, take your web content, turn it into an app. Node.js makes it really easy to throw up a small server that just repeats messages from one to another. Using WebSockets, we can have these always-on connections. So building it's really easy. Scaling it, however, is very difficult. Scaling to lots of users and devices. Scaling to many users. Well, the minute you go beyond the threshold of a single machine, you're going to start getting into distributed computing problems. You also have very lumpy usage. For example, the classic case of when you scale to many users, you have a website like, say, the front page of CNN, and it's election night, and people constantly hitting reload because they want to know the information right now. 99% of what is going to come up is not going to be new information. Wouldn't it be better if they could just get that little piece? Which you can, it's not hard to do with stuff like WebSockets, but scaling that to millions of users, where the traffic's going to drop off the next day. You have to do all this for one single day. Or the big game where people are talking about, they want to get the scores, or an Apple event. I remember a few years ago when every Apple weblog started doing the live blogging thing. And they had to say, please don't refresh. We put special code in the web page to refresh it for you. So don't refresh too much because it's killing our servers. And again, you put all this infrastructure together for one event, and then you don't necessarily need it the next day. Scaling to many devices. And I don't mean lots of physical devices, but that there are so many different devices that are all different. They all have different languages, they're different platforms, and this is going to grow. At least on mobile devices, we can say roughly iOS and Android. But in the realm of smaller things, there's more and more platforms and languages, and trying to get all of that together. This is tweeting me about my talk, which I don't need to know about because I'm giving it. Too many messages. So there's many, many platforms and languages, and each of them, each device, each platform language has different native networking APIs, which have different performance characteristics. Which is the most efficient use of battery, which is the most efficient use of bandwidth. And then we have the real-world internet, where The connection may be slow, or it may disappear, or it may come back and leave again. And things that work perfectly in the lab don't work at all in the real world, or you get 5% of your users just for some reason they have problems and the rest are fine, and it's very hard to diagnose. This is the difference between building something quickly and making it work at scale. Privacy and security. So can you trust the channel itself? Well, if it's your code, then presumably you can, if you didn't get a bug. Are you using any third-party services? Can you trust the vendor? Should it be encrypted end-to-end? What about a rogue device? Someone gets into your network and starts injecting fake information, which sounds a little silly, but consider if we did have thousands of, say, municipal CO2 sensors around the city, someone modifies it to start sending in high or potentially low CO2 measurements to hide the pollution activity they're doing. Same thing with a rogue network. The network can't trust the device can't trust the network, and a device that is allowed to access the network but starts trying to upgrade its permissions. All of these, there are known solutions to these problems, but it's a whole lot of stuff that you have to think about when what you're originally trying to do is pretty simple. And then, of course, regulatory compliance. Safe harbor refers to the ability, let's see if I remember this correctly. So there was a safe harbor agreement, which meant that data stored in the United States would be treated as under the same privacy regulations as the EU. And that was ruled unconstitutional by one of the large EU courts, so that each country can now dictate its own rules. What it essentially means is if you are storing data, it now matters where in the world you are storing it from a legal point of view. And then, of course, if you're doing anything with healthcare, it has to be HIPAA compliant. I don't actually know what HIPAA means. I just know that it involves this very lengthy process with lots of testing and lots of forms to fill out. And it's another headache when it's not the problem you're trying to solve. It's just overhead. Scaling is hard. Now, feels like we did this about 15 years ago. HTTP was simple. Anybody could put up a Linux server and throw Apache on it. But once you started to scale, you would have to buy a whole bunch of these giant Sun workstations, and that's what made Sun worth lots of money. But eventually, it got to be so cost prohibitive, and it was such lumpy traffic where you'd have a huge spike one day and not need much the next. Well, we started having content delivery networks. These are ones where it will replicate static content globally, bringing it closer to where your users are. It handles the load, billing you based on what you actually use, so you don't have to have this surplus capacity. They would always support new devices and new browsers. They knew the HTTP specs inside and out, do all the content negotiation. And most importantly, there are many services to choose from. So you could choose the ones that had the exact features or costs that you needed. And at the time, CDNs were a very radical concept. Now, if you have a large static file that's going to be shared by lots of people, you'd be crazy not to use a CDN. It's so much cheaper than building it yourself. No one would do that today. So CDNs do the hard stuff for you, the hard, annoying overhead stuff, so you can get back to the actual problem that you're trying to solve. So what we're trying to popularize is this idea of the data stream network. It's the same thing, but for data that's in motion, be it chats or hearts or likes or whatever it is, little pieces of sensor data. It needs to move around the world, be very fast, very low latency, get there, and you shouldn't have to think about how it works. You just pop a message into a pipe and it goes where it needs to go very quickly. Rather than building the infrastructure yourself and all the distributed computing, you hire a data stream network. Now, the company I work for, PubNub, is one of these. There are several other very fine ones. I think Firebase is owned by Google now, and there's many others. I would obviously prefer you to use ours, but the point of this talk is don't build it yourself. There are many good people who can do this stuff for you. And when you're looking, the most important thing, these are like the core features. Global access, sub-second latency. That's just kind of table stakes. And some sort of an SLA. I mean, the whole point to going this is that you get to scale with guaranteed reliability. Also, SDKs for any platform. What we have found from our customers is that they will initially start on iOS or Android, but as their usage grows, then they think, well, we need a web thing, we need a desktop thing, we need our developers. We wrote all this stuff in Java, but now we have a new product that's going to be done in Ruby. Do you support Ruby as well? So make sure that there's a lot of SDKs. And make sure you have access control by the device and stream, and that it's fully encrypted. Now, for access control and encryption, I don't mean that the provider necessarily encrypts everything for you or has its own model, but rather that it can plug into whatever system you're using. A lot of people have, say, LDAP for managing their users. It should be something that integrates with that. As bonus features, since the DSN is already shipping your data around, it can do some other things, really useful things, very easily, like a notification gateway. This means interfacing with the actual push messages on Apple, on iOS, which is Apple's own API, which is completely separate from Android's own API, which is completely separate from the web version and from Microsoft's version. If all the stuff's already going through the DSN, then they can offer you notification gateways for free. Storage and playback is where data, as it goes through the system, is logged. So suppose you were building a chat application. Conceptually, it's very simple. Every time a message comes in, send it to everyone else who's on that channel. Now, what happens if somebody's computer dies and they bring it back up and now they missed the last 10 messages? Well, they're only going to get the new ones unless you have actually stored those last 10 messages somewhere. So but again, you're now getting into a large distributed computing problem. Well, since it's already going through the network could do that for you. You can just say, hey, keep the last n count messages around. Anybody who rejoins can ask for those last messages. And then presence tracking, which is just how long has it been since this user has done something, or we've gotten a heartbeat from their machine, which seems conceptually very simple, but it turns out has been very difficult to implement at scale. So I'm going to show you a little bit of code snippet. Come on. We are going to build this. So what I'm doing here, our network isn't great, so we're actually getting a little more than a quarter second, but there we go. It's a little better. I want to show you how simple this is. There we go. So ignore all the HTML junk. So in the case of PubNub, you just suck in our JavaScript, connect, and subscribe. So these are the publish and subscribe keys. These are not the private keys, which you should never actually hand out to an end device, which a web page is handing to an end device. Subscribe, giving it a channel name. Every time a message comes in, calls this function, which is right here, which just says to draw X and Y. What I'm sending, every time the mouse moves and the button is pushed down, publish to channel this tiny JSON packet. And that's all there is to it. And every SDK we have for other platforms is essentially the same thing, just slightly, it's a JSON equivalent in C or Java or whatever the language is. Now, once you have this system, we found that there's about 3 ways that people integrate this into their app. They are doing many-to-one, one-to-many, or many-to-many. Now, many-to-one is a bunch of, usually it's like a bunch of sensors or a survey, a whole bunch of devices out in the field that are sending data to one collection point. And you'd think this doesn't buy you much overdoing it yourself, since it all still has to come back to your server. What you get out of using a DSN is, first of all, reducing the device complexity. All of those SDKs have been written and tested for all the different platforms, so you don't have to worry about reliability of the connection. Yes, everything is still getting sent back to your server, but that's less headache for you. The same with dealing with the network reliability and additionally security, where you can have essentially a token for every single device. And then if you've discovered that one of those devices has gone rogue, like the CO2 sensor, then you can revoke access to just that device without affecting the others. So there's still value even in the many-to-one situation. Now, one-to-many, this is the classic election night thing, where you have the same piece of information that you want to send to a whole bunch of clients. It's just like the CDN case, where somebody else is replicating your data for you. This drastically reduces your server load, and it means a small company could have an election page just as nice as the one that CNN has, without having to have CNN's budget. And you essentially get all the scaling for free, and you don't have to do anything different to your app. It's no different than if you're going to send out a WebSocket. Now, many-to-many is where it really gets interesting. If you suppose you have a chat application where there's a bunch of groups, you have millions of users, you don't actually want the chat messages to go to your server at all. It needs to go from user A to user B. Right now, you'd have to go through your server, but that's just overhead. And in fact, for liability reasons, you might really not want it to ever go through your server. Well, if you just let the network take care of it, then your server is acting much like a traffic controller. Traffic controller isn't flying the plane. They're just telling the planes where to go and giving access. Okay, you can have this. You can have this runway. You can have this runway, making sure everything's okay. But they don't have to do the actual work. So the value is the data never goes to your server, both for load reasons and liability reasons, and you have APIs to control everything. Now here's a couple real-world examples I've taken from our customers. So Periscope. Periscope essentially has almost no servers of their own. They do have some for control and authentication, but all of the work that goes from all of the computation for getting data from one user to another is outsourced. They used, I think the name of the company was Fastly, for the video streams. And then everything else is going through PubNub. So all of the chat, the presence when you're online, the little hearts that you can tap on, all goes through our service, and it never has to hit their servers. What's interesting about Periscope is they were a separate company, and while they were planning to scale, they didn't plan to scale quite as fast as they did because just before they launched, they were bought by Twitter. And so everybody knew about it, and they immediately jumped to millions of users. And they were able to do that because they had started by using a data stream network. Car sharing. Pretty much every company that does car sharing other than Uber uses us or one of our competitors. Uber has the money to build their own. I still wouldn't recommend it. With car sharing, you're sharing the geolocation. You are sharing geofencing. So when something comes in range of one of the endpoints, chatting between the parties, and all the statistics about how long the car took to get there, and general analytics and logging all goes through the same system. A large healthcare company, which I'm not yet allowed to say who it is because they're knowing about those things, but they're starting with doing chat from patient to caregiver and back. And so this is where being HIPAA compliant really made a difference. They were able to launch without going through all this extra vendor testing. And this is really exciting to me because it's starting with chat, but eventually it will move to devices. If you are sick, the last place you want to be is a hospital because that's where other sick people are. If you are not sick, then you definitely don't want to be there. So if you are being kept for, say, observation, the doctor keeps you in the hospital for a couple of days, well, you're more likely to get sick while you were there. What if there was a way the doctor could observe you real time, but let you go back home, where it's a lot cheaper, where all your stuff is, where you're going to be comfortable, and when you're not around lots of other sick people or taking up a valuable bed? I think this is going to be the future of healthcare, where the doctor can send you home, and it doesn't even have to be an app on a phone, which might not be reliable given consumer hardware. It could be a piece of medical equipment, but it's charged once at the hospital. It just has to last a few days on a battery, sends real-time information right over the cell network, and has emergency communication. So if they see a sudden spike, the doctor could actually come in and send you a voice message saying, hey, I want you to drive into the hospital right now. But since 90% of the time, everything will be fine, or they're just collecting data, you could do that from home in a safe, secure way. The Speak Free is another really interesting one. This is a nonprofit which helps refugees starting in the Middle East and into Europe, helps refugees find, hook up with NGOs, non-governmental organizations that can provide them with services. And it has to do two things. It has to connect one group of people with another based on their physical location. And most of these people don't speak the same language. So it's actually a chat application which does real-time translation using Google Translate from one language to another so that people can get immediate access right when they need it. And they also had essentially no budget. So by going with a DSN and outsourcing the translation to Google Translate, they were able to build in a few weeks their initial prototype that they could launch to I think it was about 10,000 people in the initial launch at essentially no cost. So actually I showed you the demo already. So let me tell you a little bit about PubNubs. We have 15 data centers around the world. We have 75 plus SDKs, so that's for a whole bunch of different languages. We do embedded hardware like Raspberry Pis and Arduinos, all the way up to Java on IBM's cloud server. The basic features are publish, subscribe, storage, playback, and presence. We've been around for 4 years. The most impressive thing I just learned was we're now doing 1.2, I think, billion transactions per month, which is actually more than Twitter. There's a lot going through our network. And we charge by the month. There's no contracts. So if you don't like it, you don't have to pay us. It's not like traditional enterprise software. I think this really changes the way people build applications. And we have a free tier that gives you, I forgot to look up the numbers. I think it's 1,000 devices and 1 million messages a month. Like until you're shipping a product to a large number of people, you are never going to go through this free tier. So it's very easy to get started and prototype with stuff. So whether you go with us or one of our competitors, please don't build your own. Focus on what your app is actually supposed to do. Getting data from one place to another is just part of the job in the network. Outsource that to somebody who specializes in it, and then focus on your app. Now, we announced a couple weeks ago our kind of next generation thing, and this is where I want some alpha testers. So today we have data that is moving in the network. Tomorrow what we'd like to do is move some of the computation into the network. So imagine you have a junior high school chat application. And again, you don't want the data to go to your server. It goes from one user to another. But you might want to filter some profanity. Conceptually, this is very simple. It's if message contains one of this list of words, then rewrite it or send an error back to the user, whatever. Doing that at scale, again, is very difficult. What if you could move that small piece of computation into the network itself? So as the data goes in the stream, it doesn't have to leave the network to your server, do some computation at scale, go right back up. It can just go straight through. Well, you could write what we call a block. Other people call them microservices that essentially live in the network and do this small bit of computation. A TV voting app. Suppose you like watching Dancing with the Stars. I'm okay with it, but my wife really loves it, so we tend to watch a lot. On Dancing with the Stars, right now, you vote and then they tabulate it up the next time. Well, what if it is a live show? Why can't people vote while it's actually happening? And the people who are producers don't actually need the individual votes to hit their server. They just need to know the sum of the votes. They just want the tally at the end. And real time, have it aggregated so you can see the votes go up as people are actually voting. This is another case where a small bit of computation is really annoying to implement on the server at scale, but could be done by the network trivially. A forest monitor. This one I find really interesting. So imagine you have thousands of temperature sensors scattered throughout a forest. Say in Northern California, where we're having all these forest fires. Most of the time, they're sending out a little blip of information every 30 seconds or 5 minutes or whatever it is. And you don't need that information. Maybe you want to store it for long-term purposes, but you don't need it to be real-time. But occasionally something spikes. Well, if you want to record that spike, you're going to have all of that data come back to your server and be doing a real-time real-time analysis on it. Well, what if the network could do that for you, where it records everything to a log, or it sends you an average once every 5 minutes, but if something spikes, it hits this threshold, and then immediately sends out an alert. Say, hey, there might be a forest fire starting right here. Get on it soon. So we call these microservices, or we call them blocks. That may change a little bit, but they're microservices written in JavaScript and SQL. Nobody needs another language to learn. Start with stuff that we already know. And if you would like to join our beta test, which is going to start next month, then go here, pubnub.com/products/blocks. And that is all of my stuff. So, do we have any questions? Yes.
Have you guys looked into becoming a more persistent, like almost like a database as a service? If you have all this data and you're already buffering it somewhat,
right?
Why not just become the database?
Because there are a lot of companies who do that already, who are really good at it. And what we've learned from our customers is that they want us to make it really easy to get stuff out of our system to the database. So with blocks, we're going to have a bunch of prefab blocks that do things like drop into one of Amazon's storage systems, or Kinesis, Amazon's, I forget, and integrate with Apache Spark and other data analysis systems. So it's ultimately, our customers have said, we love what you do, make it easy to get into these other systems. So that's what we're going to do instead of making our own. Yes? No, it's just that they are modular pieces. We called them. Like I said, I think we may change the name because blocks just seems such a generic term. So, yes. Oh, yes. So the question was, if I get this correctly, we're talking about content versus stream, as in CDN versus DSN. Yes. So it's data, static data that doesn't change. You'd use a CDN, generally stuff over HTTP. Data that is real time, where you want it in under a second, that is what you'd send through DSN. How does this differ from things like RabbitMQ? It's true, there have been enterprise message buses around for a long time. Ultimately, those still require you to run your own infrastructure and deal with redundancy and reliability. You can think of it as, we've run a really nice version of RabbitMQ in the cloud for you and give you a really clean API to access it. So it's really about not having to run your own infrastructure. Any other questions? Yes, sir.
When you say that the messages are going from client to client, they're really going through your system, right? Not coming to mine, but they're going through.
Yes, they're still going. When a message goes from a client to client, they are still going through a computer somewhere.
Right. And the blocks is on your infrastructure, not like distributed.
Right. If you run when blocks is shipped, it will be running in our infrastructure. The difference is you don't have to manage an infrastructure, and we have it replicated around the world. We can also do things like, for safe harbor, you can say, for legal reasons, I need all my data to only live in Germany. That should just be a checkbox. It shouldn't require re-architecting all your stuff.
Your servers are HIPAA compliant?
Yes. We just finished that like a month ago. And I don't know exactly what they had to do. I just know it was a big crunch time for engineering, and they were really nervous when the inspector came. But yeah, it was all good. Yes. Well, there are certain customers who just have to have that, and that makes the difference. Any other questions? Yes, sir. Well, okay, so the question was, what's the difference between us and Firebase? I have to confess, I'm not an expert in Firebase's system. Some of our evangelists have done similar demos to what theirs have done, so that I know that they have a real-time component, but I believe it's part of a larger, they're owned by Google now, I think. And they do have a persistence mechanism. So I would say they do several things, whereas we focus on the DSN portion. And that's what our customers have said they want, is they want us to focus on that.
So are you
Well, generally, so the question is, do you have to specify how long we keep the data? Generally, data isn't kept at all. It goes through our system. It's completely transient. Only if you turn on the playback and storage and playback service is it recording, and then you can determine what gets saved and for how long. So the question is, do users have to be online to receive data? Like, are we doing any sort of buffering? Is that what you're asking? By default, no. And that's why we have the storage and playback, where it says, okay, this is real-time data, but sometimes people are disconnected or they may be offline and they want to come back tomorrow. Then how far back should we allow it to go? And that's entirely up to your application. Ultimately, every application is different. So we just made an API for you to choose how much. Typically, it's under 1,000. Generally, the data that goes through is like, if it's older than a few minutes, it may not be useful anymore. Like in the case of Uber, I don't really care about where the car was an hour ago. I want to know where it is now. Any other questions? All right, thank you very much.